Okay, so we're gonna try to visualize a autoencoder, and I mean, I guess we're trying to put some level of human interpretation on like what an autoencoder is doing, particularly if it's compressing, like, like if the so this is like the setup, like we have like an image, and we're gonna make these images smaller because like 16 by 16 is too large. But we have these images and it's supposed to output the same image, and so we just reshape the image to a vector because we're doing like densely connected layers, and then we map to like a smaller vector, and we map it back up to a large vector. So like there has to be theoretically some sort of like compression that's happening, and so it's not really clear if that is interpretable in any way, like what exactly is being compressed, and like how is it compressing anything, because I mean, like, we're literally just computing like dot products. So with tan H's. So I think what we're gonna do in this video is we're gonna keep this scheme, and we're gonna make these images like, I guess, 8 by 8, something smaller, and then the yeah, we have to I think we'll then visualize the internal activations, I guess, like per image on a batch. So it's kind of going to be annoying because I have a visualization now where it's like per unit, and but we don't want it to be per unit, we want it to be per image. So oh no. Let me get the viz working here. Yeah, so I think what we're going to want to do is we're going to want to say, first of all, these images need to be much smaller. They're 16 by 16, and like I think we'll do like 8 by 8 perhaps. And then we need to look at the encoder weights and the decoder weights. And then the activation, like this is like the hidden layer activation. And this is presently like per unit. Each square is a unit on the entire batch. And we need to rearrange it so that each square is an input and it contains all of the units. So that really shouldn't be that hard. And then it's like, we'll be able to, so then what we want to do is the internal layer, we will make it the same dimension as the images so that there is no compression, right? So theoretically it will learn a perfect, I mean, I would assume it would learn like the identity function, which means like each unit in the hidden layer is just looking at, like, it would have a 1 for the corresponding pixel in the input and a 0 everywhere else. So that would be like the identity function. And yeah, so like both layers should learn identity functions, and then like once that's working, then we can say like then we can start compressing the hidden layer to see what's happening. So I need to add some columns to my UI. Okay, so we're gonna have another column here, which, I mean, it's almost like you don't even need to visualize the inputs, but we just will. Inputs. So this is the input batch. Input batch. And then we want the encoder weights, which, like, you know, for right now, they're not encoding anything because there's no compression. Okay, this is activations, and I didn't actually need to delete this, but that's cool. This is the decoder weights. Decoder weights, right? That's the whole thing. So then, oh, I'm running this. Oh yeah, I was gonna do like a matrix. Yeah, we're not doing matrices anymore, so we're just keeping with this. I mean, I kind of like the idea of, like, you have the encoder with like a full dimensional hidden layer, and then you start compressing, and then you're like, okay, what is it doing? What is it doing when it's compressing? Because, I mean, technically, like, you know, like, we're using like square or like rectangle data, and I mean, it seems like you can represent every image with 4 numbers, right? Like, you know, the X and Y location, and then the width and the height. So technically, you should be able to, like, compress, you know, like, the inner layer down to like 4 numbers, 4-dimensional. But yeah, I mean, you probably won't do that because, like, I don't think you can represent, like, in the decoder, I don't think the decoder has any way of saying, like, you know, okay, like, the first number is the top left corner, you know, and then, like, drawing that. I mean, ultimately, all the decoder can do, I mean, the decoder is literally a dictionary of images, and you're just taking a linear combination of this dictionary. So, yeah, we're just trying to figure out what's happening there. And so, okay, so first of all, I was going to make the images smaller, and batch size, I don't know, let's make the batch size smaller as well. And so the batch size will be 4x4, and image size, we yeah, we need to modify this. We need to say, like, 8, I don't know, -3. Like, you need to allow enough. This is like the upper left corner of the rectangle. And we want to say they can go up to size, I don't know, 5. Well, the max, yeah, I think it's okay if it goes off the border, but I don't know. So, okay, so anyway, so that's the images. So the images are now 8x8. And then, okay, we create the neural net, and so each image has 64 numbers, so we need the inner layer to be 64. And Okay, so then we need to draw all of the items. So we need to draw the inputs, the encoder weights, the activations, create canvas. Yeah, okay, so we need canvases. Okay, so like the inputs are 8x8 images. So we can just copy this section. So these are the inputs, and I already forgot what I called it, inputs. And so this is inputs canvases. We don't really, well, we do need to redraw this whenever we have a new batch. So anyway, the batch size is 16. I'll just say batch size, and they are, this is image size, and inputs canvases, inputs div. Okay, let's see what that's doing. It's probably crashing somehow. Cannot read property a pin child of null at 118. Yeah, that's fine. I'll just ignore that. Okay, so probably just say don't show again. Okay, so the activations are going to be per batch size. So like for each image in the batch, we're going to show all of the activations of the internal layer. And so that needs to be image size. These are also image size. Okay, and I think that's all good, except this needs to say activations, canvases. Okay, so that's like the activations, input batch, encoder weights. Oh, I see what it's doing. This is encoder weights, activations, decoder weights, outputs. Okay, so yeah, let's do the encoder weights. So the encoder weights are it's, well, we want to visualize them like as images as opposed to like, the encoder is a 64 by 64 matrix, but so I think we want, yeah, there's 64 units, so each of the 64 units is going to be visualized as an image. It's like a lot of canvases. Okay, so then the activations, the outputs, and then the decoder weights. So like, you're probably not supposed to use this many canvases on a single application. But hey, we're neural net programmers, you know, like we do stupid stuff. Okay, so encoder canvases, decoder weights, and there are 64 of them. 64 of them. And batch size, and these are now image size. Okay, I think that's like all the canvases we need. Okay, so then we need to go to the actual drawing part. Okay, so we're gonna try to draw them in order. So let me first draw the inputs, which is gonna be very similar to the outputs. Recompute, activations, yeah. Okay, so this draws the inputs. And I think the inputs are just a global variable. Oh, it's called images, I think. Yeah, all right, fine. Okay, so draw inputs, it's just called images. And there are batch size many of them, and then we need to get input canvases. I think I called it that. Yeah, input canvases. Oh, inputs canvases. Great. And this is image size. This is image size. Oh yeah, but I think, yeah, I mean, okay, so let inputs equal, I think images dot array sync. I think you need that. And then okay, so that should draw inputs. Oh no. Okay, it doesn't like 89. Why not? Oh. Fair enough. There you go. Look at that. That's amazing. This is the input batch. Now, why are they all squares? Okay, so we screwed up the code here. Where are they all squares? Oh, this is like the max. Yeah. No, the max size needs to be 8, I guess. Cannot set priority 4. Huh. 35? Oh, okay, so I have to manually check if we're off, if we're out of bounds. Okay. if R is less, has to be strictly less than image size, I think. And C is also strictly less than image size, right? Oh no, I screwed up my brackets. Okay, here we go. Oh, beautiful. Okay, those are some beautiful rectangles. Okay, so then now we need to draw the activations. And this is going to be per input, like per image. Okay, so like, which shouldn't be too hard, actually. Recompute activations. I think I just need to switch a number. Well, okay, it's gonna be, there's gonna be batch size of them, and we're drawing the images. Yeah, this is gonna be annoying. Image size. So L1. Also, these are called axe. They're called axe canvases. And L1 outputs, like, isn't this organized like by batch? So if I just do that and then say image size and then get rid of this, that'll just magically work. Oh, it did. Those are 8 by 8. Yeah, they're supposed to be 8 by 8. So encoder weights. Okay. Okay, let me just fix this. Batch size. Image size. Oh, cool. Like, yeah, these kind of match up. Wow, it's like you don't even have to train it, and it already kind of works. Which is very weird, because, like, this is the internal activations, and, like, these should look similar. Okay, anyway, so let's do the weights. L1 weights. Draw inputs, draw the internal activations. These are the encoder weights. And I think I called them encoder what? L1 weights. Yeah, but okay, I called it encoder canvases. And there are, for right now, it's the same as the image size, which is 64? Yeah, 64. That seems like a lot. And the image size is just 8 by 8. So, is that cool? Oh yeah, that's very cool. Alright, now we just need to look at the decoder weights. I mean, it's like, this should work perfectly because it's not compressing anything. Like, these weights should become identity functions, or like close to, meaning they should just pay attention to a single pixel. And then like these activations should just look like the images. That doesn't quite seem to be happening. Alright, let me get the decoder weights, which I'm not sure how I'm going to get the decoder weights actually, because it's just the weights of the final layer. So it's going to be let me just call these decoder weights, and these are decoder canvases, and this is decoder weights, and I think like it's just neural net dot get weights, except it's going to be like layer, I don't know, 0, like 0, 1, 2 maybe. I guess that's correct. I don't know if that's correct. Console.log decoder weights. So it's, well, yeah, I mean it should be 64 by 64, so. Okay, let's see what this does. Yeah, there you go. See, like, it doesn't really seem to be working because, like, on every new batch, it's not correct. Because, like, there's all this, like, noise. I mean, it kind of works. But basically, like, the internal activations should look exactly the same as the input batch. And they don't. Uh-oh, what's happening here? Something's happening. I think, okay, let's make the training quicker, you know? Actually, I don't think I can make it quicker. This is basically, we're maxed out. See, I mean, it's just like, it's supposed to learn the identity function, like, but it's, so like, every one of these weights should have a single, like, white pixel indicating that it's paying attention to that pixel in the input. and we have as many weights as there are pixels, so they should just directly learn to pay attention to one pixel. But that is just not happening. Neural nets are failing me. What if I turned off using the bias, right? I mean, because we don't technically need the bias. So let's make this false and make that false. And yeah, let's make this quicker, I think. So we'll double the rate of training. And I feel like something broke. $255. Oh, it's because I changed. Yeah, it's a different. This is no longer correct. What should be 1 now, I guess. Yeah. Oh, what is happening now? So I don't know if this is because I changed the bias or because I changed the learning rate. I mean, it's still like it's not working. Like whenever it changes to a new batch, like it should be perfect, like without training. This is not working. Come on, neural nets. F5. Okay, slow down the training, I guess. I don't know, like what if we make it really fast? Let's just see what that does. Oh my goodness. So that doesn't work at all. Yeah, so we'll just turn that back down. What if I don't do 10H? What if I just say no activation? I think you can say none. Or like linear. I think those are the same. So like it seems like it's working better. Like every time it switches, it should just have very low noise. I mean, every time it still has noise though, like, but I guess smaller noise than previously. So, but it's learning like an uninterpretable encoding, right? Like this image corresponds to this encoding, which corresponds to this output. So, I was assuming, these two images would look the same. But they, uh-oh, something happened. Alright, what if we do it where we just use a single batch? So like we don't reset the batch every time, or yeah, okay, so like just use a single batch. Okay, so like it learns this single batch perfectly. Kind of. So I'm not, why is it, update weights. Alright, well listen, we learned something, which is that unless I'm drawing this incorrectly, that is kind of possible actually. Let me see what that, draw inputs, draw weights, draw activations. Yeah. What is the shape of the activations? 16 by 64. So this 16 is what? That's the batch size. Okay. So that's the batch. And then, yeah. I think that's right. So the internal activation is not like interpretable. And the weights are also not interpretable. So there you go.